9.2 through 9.54, we're going to be doing arithmetic and geometric sequences and series. And let's get going. All right, move this out of the way. All right, sequence is a list of numbers in a specific order. A series is the sum of that sequence, and you can have arithmetic or geometric. Each number in a sequence is called a term, and the notation is important to understand. I think that sometimes with the different notations it can be confusing, and you get frustrated because of just the way it's written. A sub 1 is the first term, A sub 2 would be then the second term, and so on. A to the nth is the nth term, which means to any particular number. It could be the 14th, it could be infinity. It's some number we don't know, right? An arithmetic sequence, the difference between the arithmetic and the geometric is very, very simple. The arithmetic is found by finding the common difference, which means you're going to take the second number and subtract the first number from it and see if that is a constant throughout all your numbers. If that's the pattern, then it's arithmetic. So adding and subtracting is arithmetic. So again, take your second term and subtract the first term to get a common difference. That will be denoted as a D when we're working on these. And you need to make sure that it also works for the second and third, fourth terms. Now, that's different from a geometric sequence, whereas instead of subtracting, you're going to be dividing. Okay, so you're going to look for a common ratio instead of a difference. Difference is subtraction, ratio is dividing, and we're going to have that denoted as R. Okay, so you'll take the second term and divide the first term into it to see if you get a common ratio. And of course, as it did the arithmetic sequence, you also have to make sure that it's true all the way through the pattern that you have. All right, so let's look at some of these. All right, I have 12, 16, 20. And then I need to know the next four, and I need to know if it's arithmetic or geometric based on what the pattern is doing. Is it subtracting a common thing, or is it dividing a common thing? Okay. Looking at this, I'm going to look at the second term compared to the first term. If I did 16 divided by 12, let's see what that would become. 16 divided by 12 is 1.333 repeating, and then 20 divided by 16 is 1.25. So it's not geometric because the constant is not the same. But if I did 16 minus 12, I would get 4. And then if I did 20 minus 16, I'd get 4. So that would mean that it is subtracting at a common difference. So I would circle D for difference. Whoop, let's make something so you can see it. D for difference. And that common difference was 4. And then you just have to find the rest of these terms. Well, if you're going to find this term, okay, that would mean that you would add 4. So that would be 24. The next one would be 28. Next one would be 32. And the next one would be 36. Okay? So you just have to decide, and this would be arithmetic because we're subtracting. Okay? Or if you subtracting or you're adding to find the rest of the term. So addition, subtraction is arithmetic. Multiply, divide is geometric. All right, let's look at the next one. 6 minus 3 is 3, but 12 minus 6 is 6. So that's not arithmetic. That means it's got to be a ratio. Or it could be none, but let's just check it. 6 divided by 3 is 2. 12 divided by 6 is 2. So yes, it is a ratio of 2. And that would mean that we would multiply to get the next four terms. So 12 times 2 is 24. Times 2 is 48. Times 2 is 96. And times 2 is going to be, I can't do it, been on break too long, 192. Okay, so this would be geometric. Very easy. You just have to find the pattern. You have to decide. These are sequences because they are in numbers in a specific order. Okay? All right. Now we want to find the requested term. So they're asking you to find A4, A sub 4, which is the fourth term in the pattern. Okay, you can plug into a formula or you could just actually do it. So if it's 3 plus a negative 5, and that would be the second term. So A1 is going to be 3. We want to know there's 2, 3, and 4. We want to know A4. All right, so if I add a negative 5, so it's 3 plus a negative 5, which will make me have a negative 2. All right, plus a negative 5 is going to make a negative 7. Plus another negative 5 is going to make it a negative 12. Or you can plug it into this formula, okay, where this A sub n is trying to find a specific one. In this case, we would be looking for A4. So you could write it as A4 equals, the first term is 3 plus, and then n is, we want to get to the fourth term, so that's going to be 4 minus 1. And the difference, the common difference, was negative 5. And this is multiplying, okay? So it's 4 minus 1 is 3. 3 times a negative 5 is a negative 15. Negative 15 plus 3 makes negative 12. Okay, so you can do it either way. This formula is going to be on your formula sheet. You will not have to memorize it. So if that's what you want to do, that's fine with me. Or you could actually just figure it out, just like I did, made my blanks and figured it out. But you may not want to do that when you're asked to do like number 2, where they want a sub 13. That takes a little bit of time. I'm going to use my formula on this one, and I'm going to have a sub 13 is equal to, the first term is negative 5 plus, and then I want to find the 13th term, and my common difference was 7. All right, and again, this is multiplication. 13 minus 1 multiplied to 7. You must do that first. So 13 minus 1 is 12. 12 times 7. And then add negative 5. And you get, whoops. I knew as soon as I did that. Whoa. This is what happens when you go on spring break. You really just shouldn't. Hang on. Now my calculator's got this weird message that I've never seen before on here. All right, so hold on. Oh my gosh. 84 minus 5. 79. So this one should be A13. A sub 13 should be 79. All right. This one, again, you've got to watch though. Notice how they gave us D's right here. That means that we were following a arithmetic sequence because of the D being the common difference. But these next two are R's. That means it's geometric sequence, which means we'd use a different formula. Okay, and again, these formulas are on your formula sheet. Okay, so I'm going to go ahead and plug this in. I want to find a to the fourth, so I'm going to have a to the fourth is equal to, and that looks like a 9, but it's a, is equal to a sub 1, which is 7, times, what's my r? 2. And that r is what's being raised to the n minus 1, so that's going to be 4 minus 1. So the 2, 4 minus 1 is 3. 2 raised to the third power has to be done first. Okay, 2 to the third power is 8. 8 times 7 is 56. Okay, so a sub 4 is 56. The next one, we want to go to a sub 6, which is going to be a sub 1, which is negative 4. And that's times r, which is negative 2, raised to the, we're looking for the sixth one, so it's 6 minus 1. 6 minus 1 is 5. Okay, so you have to be careful on this one. It's negative 4, negative 2, raised to the fifth. Okay, this has to be done first. negative 2 to the 5th power is going to be a negative 32. Negative 32 times negative 4 is going to make 128. So A sub 6 is 128. Okay, be careful with this because this power is being raised to this negative 2, and if you don't use parentheses, it could mess you up, especially if the power would have been an even number and you didn't use parentheses when you were raising a negative number to an even power. That could be a problem. So be careful with this. If you want to type it in just like this, the calculator will do it in the proper order. Should give you the same number. All right, so now it says find the nth term. All right, so we're looking A3. So all we're doing on this kind of stuff, they've given us a formula, and they're saying A sub 3. We just plug that 3 in for n, and we get our answer. So this is very, very, very simple. So it's going to be 3 times 3, because we're looking for the third term. 3 times 3 minus 4. So 3 times 3 is 9. 9 minus 4 is 5. So A sub 3 is 5. Okay, this one is A sub 4, so I'm going to take negative 2 and plug in 4, which will give me negative 8. This one is 2 raised to the n minus 1, and we want A sub 5, so we're going to say 2, and then 5 minus 1. Well, 5 minus 1 is 4, so 2 to the 4th power should be 16. Okay? Very, very simple. If they want you to find the nth term, you just plug in whichever number they give you into n. Very, very easy. All right? All right, now, arithmetic series and geometric series is a different thing. That's going to be the sum of a sequence, or the sum of arithmetic or geometric series. So let's go back and let me show you what I'm talking about. Suppose this one right here where we had all these and we had to find all those terms. Series means you would add these all up. That would be the sum of that sequence. Okay, that's what they're finding out with this. And this is a uppercase sigma. Okay, the Greek letter sigma, uppercase. Remember the lowercase was a little standard deviation thing, but this is the uppercase one. And you can use this to stand for a series, okay? This little sigma thing means sum in Greek. Okay, so what you'll do is you'll have a starting number, which would be like your first term, and you'll have an ending number, which would be the last term. And then they'll give you a formula, okay? Or sometimes you'll have to come up with this. Okay, we'll get to that too, but for now we're just going to put them in and plug them in. What that means is each one of those that you plug into the formula, then you're going to add that to the other ones that you have to plug in. For example, all right, we have this with the 7 on the top, n equals 1, and all this 2 times n. What that means is this is your starting point, this is your end point. You start right here and you plug 1 in for n. 2 times 1. We need to go from 1 to 7. So we have to do 1, 2, 3, 4, 5, 6, and 7. We plug them in, and every single one of the numbers between here and here, whatever they are. Then whatever those totals are, you add them up. So 2 times 1 is 2. 2 and 2 is 4, 2 and 3 is 6, 2 and 4 is 8, 2 and 5 is 10, 2 and 6 is 12, 2 and 7 is 14. And then you add those totals up, and that will give you your sum. And that's fine if you have a small series. But sometimes you have big series and more complicated problems. So you may want to use your calculator. Okay, so let me show you what you do. We'll pull this up. All right, to do this particular one, we start with second step. And we're going to go over to math, And we're going to hit number 5, which is the sum. Then we're going to do second stat again. This time we're going to go to ops, and we're going to hit number 5 again, which is sequence. So you have sum, sequence. Then you're going to type in your formula. In this case, my formula is 2n. So it's 2x. And you put a comma. And then you're going to put whatever letter you're using, which I use x's all the time, in comma. And then you're going to put your first term, which is 1, and a comma, and your last term. And you got to make sure you have all the parentheses. If I have 2 parentheses going this direction, I have to have 2 parentheses going that direction, or it will give you an error. So I have 2 going this way and 2 going that way, and hit enter. And there you go, 56. A lot quicker than doing all this. So I would suggest that you get used to using this. Let's try it with this one right here. So I'm going to clear this out. All right, so it's second stat 5. Oops, go over to math first. 5. And then second stat ops 5. Okay, now you're ready to put stuff in. You put your formula in first and do it just like they show it. Okay, 4 parentheses, 3 parentheses, raise 2. Now, because it's raised into an expression, I'm going to go ahead and put more parentheses. I like to have that separated. Okay, that's all raised to that. And then I have a comma. And then I have my 1. Whoops, go back. I have to have my letter, my variable, which would be x. Then my 1. Then my 5. Now, I have 1, 2, 3, 4 parentheses going that way. So I better have 4 going the other way. So now I have 1, 2, I need 2 more. Okay, and hit enter. 484. So this would be 484. Much quicker than calculating it out. If you needed to, you would have to put 1 in for n, get your answer, and then put plus, and do it every time from 1 to 5, then add them all up. So it's totally up to you what you want to do, but I think this is a lot easier and a lot faster. All right? Now, the last part is talking about finite and infinite series. Finite means it ends, so that means your series is going to have a beginning and an ending term. An infinite series is a series that has a beginning term, but it goes on forever. In other words, infinity. Okay? And that's why you get the infinite series. For example, if you have 10 plus 20 plus 30 plus something, bunch of dots, and then plus 110 plus 120, there's an end and a beginning. This would be a finite series. And you would use this formula, which is also on your formula sheet, to calculate that out. First, though, I'm going to tell you, if you do that way, you're going to need to find n. So you need to know how many terms are between first and last term. So in other words, it's going to go, this particular one's going up by tens. We can see that. But we have to know what all goes in between here. Well, it goes 40, 50, 60, 70, 80, 90, 100, all in between here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 would be your n. Okay, n would equal 12. Now, once you have that, you can plug it in. You've got your answer. Okay, but you may have to do a little bit of calculating to see what all is in between and how many numbers that is. Okay, if it's a finite series. If you have a problem like this, 100 plus 60 plus 36 plus 108 divided by 5 plus dot, 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 and there's no last number, this is called an infinite series. And you would use the formula that has the summation. That's what this S is. That's for sum, which is what you're doing with your series. This is the sum. Okay? And this one has the infinite. Okay, so it's summation of an infinite series. You plug in a sub 1, which you have 100, divided by 1 minus your ratio. Well, you have to find your ratio. 60 divided by 100 has to be the same ratio as 36 divided by 60. Plug it into your formula. Okay? So you should be able to do that without any problem. Now, to find the summation notation of this problem up here, like I said, we had to find what n was first. Use the arithmetic sequence formula, solve it for a, which will be the formula for the summation. Then take the last number and substitute in for a and solve for n. N will be the ending number, and then use the calculator from there on in. Alright, so we figured up without using all this, but you can do that. You can take this and solve it for n very easily if you didn't want to go and count all those. Alright, so we took a sub 1, which was 10. I'll put that right here. Plus n minus 1 times whatever my difference was, which was 10. Well, I'll do my distributive property, okay, 10n and 10 times the negative 1. That gives me this equation right here. Well, that ends up being just 10n. When I solve it by plugging in the very last term, 120 is equal to 10n, and divide, I get n is 12, okay? Then you can plug it into your calculator and go from there. And this will give you your answer, okay? So either way, if you had to solve it out one way or the other, you can figure it out. All these formulas are going to be on your formula sheet. You will not have to memorize them. You just have to make sure that you know which ones to use. Whenever there's a D in the formula, that means it's arithmetic, which means it's a common difference, which means you had to subtract to get the same constant. But if it's an R, then that means it's a common ratio. That means it's geometric, which means you had to divide to get a common ratio. So you'll be able to tell the difference between the two. And all the series ones have an S, okay, for series. So you're either going to have to work with this formula with the S's or the summation sigma formula. Either way, you should be able to do this without any problem. Okay, this is a very easy section. Shouldn't have any trouble with it. You may have 3 or 4 at most questions on your SOL test, but this should be no problem for you. But if you have any questions, come in and see me and we will work on these together. Okay? And that is the very last of your brand new notes for the entire year. We are completely done with our video series, so it's been great working with you this way, and I hope this has been helpful. And again, thanks for listening, and I'll see you in class.